got it.
Okay. Today, students, we're going to learn how to install our gauges correctly on a refrigeration or air conditioning system. The first thing we have to do is make sure our low and high side gauges are at atmospheric or 0 psi. Let's see here. The low one is at 0, but my high side is in a vacuum. So, well, that tells me I need to calibrate it. And how do we do that, right? We take this plastic plug off the calibration screw. We get a small screwdriver we're going to go clockwise to calibrate it at 0 atmospheric pressure. Let me back up a little bit because I forgot something. Making sure that you have no pressure or vacuum on your hoses. And how do I do that? I just crack it a little bit to relieve any pressure that could have been in there. In this case, I didn't have any. But if you calibrate it with pressure in there, you might think you have it at 0, but you might not be at 0. So always make sure that there's no refrigerant and vacuum on your gauges. So the first thing I'm going to do is to make sure that all my hoses are snug on the manifold gauge set, and make sure that my gauges are closed. The next step is, I always try to remember this step, I put the red on first. But here's something you need to have on your gauges: a low loss fitting. And the reason you have that is to not only prevent frostbite, but also to minimize the release of refrigerant into the atmosphere. So I'm going to get started on the system right now. So the high side, you might ask me, which one is the high side of the system? The way I remember this is, the smaller of the two pipes is the liquid line, or the high side, and the bigger of the two pipes, we call that the suction line. So the red would go on the high side, which is the liquid line. Don't be scared, you might hear some hissing when you actually install these low loss fittings. What should happen if the system has positive pressure, you should start reading PSI on your high side of the system. Am I done? Not yet, because when I attach it, I have refrigerant, but I also have air, which is a big problem for a refrigeration and air conditioning system. So the way I fix that is, I crack and let a little bit of Freon out to purge the air out of that hoses. Be careful though, and I do have to warn you, I actually should be wearing gloves, but since this is the high side and there's liquid in there, you can get easily frostbite. So be very careful when you're dealing with the high side of the system. The next step is attaching my low side of the system. And now I should be reading positive pressure on the low side. Now, like the high side, I have refrigerant and air in the low side of the system. What I'm going to do is crack it until it bleeds a little bit, or purge some of it out. Then I stop. Now I can actually run the unit to check my pressures. I don't know if you want to run the unit or not, Oscar. I guess we should, right?
Yeah. Now, also, when the unit is off, we call that equalized pressure. Is that correct?
Yes, equalized pressure. And the reason Oscar's saying that, because the refrigerant cycle, the compressor is not running. So both the low side and the high side, if there's refrigerant in there, should be equalized to whatever temperature of the surrounding air around that unit is.
Now, for everyone to notice, is that a correct way of knowing you have the exact refrigerant in there that you need? Or it just gives you an idea that there is refrigerant inside the
Very
unit?
good question, Oscar. Really, what this is telling me, that the system is not empty, but it's not really telling me if it's charged correctly.
Okay.
The only way we know is by actually running the system and checking my low and high side pressure, which you also have to check superheat and subcooling, which we're going to discuss in a later video.
All right, let's get the system on.
Okay. So what I do is I don't tell the homeowner to do this. I actually go inside the home, go to the thermostat, and place it on cooling, and I bring the temperature down all the way to make sure the system does not shut off on me. Now here's where a lot of technicians make a mistake. They grab the gauges and automatically think it's low or overcharged. What you have to do is let it run for 15 minutes and then check if your pressures are low or in the correct range. You might ask me, how do I know if these pressures are correct? Should I say it, Oscar, or should we leave that for another video?
We'll leave that for next time.
Okay, we will discuss that in the charging video. So let's pretend that we charge the system up. Now there's a wrong way and a correct way to remove these gauges. And you might say, well, why do we have to do this procedure? The reason we have to do this procedure is to minimize the loss of refrigerant inside the system. Because even an ounce could affect the performance of the air conditioners. So what we have to do is keep the unit running, but remove the high side hose first. Notice that the high side did not drop to 0 psi. And the reason for that is my low loss fitting is keeping the refrigerant inside the red hose, which means that all this refrigerant, I can put it back into the system. And you might say, how do I do that? The first thing I do is attach my red hose to the back. Let me go back a little bit. Make sure that your hoses, and I see this a lot, does not touch the floor. And the reason for that is, usually in a refrigerant cycle or in air conditioning, there's oil. And oil is going to attract dirt, and that dirt can go into the system and contaminate the system.
In other words, the technician should regard their manifold gauges as a toothbrush. It's very personal, and you have to keep them clean.
Yeah, if any contaminants get in there, basically we have to start fresh and recover all the refrigerant. We try to minimize the chance of doing that. So now what I'm going to do is I'm going to open counterclockwise the high side valve on the manifold inside. So what am I doing with that? When I'm opening this, the refrigerant is traveling in the manifold gauge set and going into my yellow hose. There's a problem here, because since I opened that manifold gauge set, I have air and refrigerant inside the yellow hose. So what am I going to do is, I'm going to crack the yellow hose until some refrigerant come out to bleed the air. Am I done? Not quite. The refrigerant is stuck in the manifold gauge set on the yellow hose. I want it in the system. So what I'm going to do is go counterclockwise and open the low side. Let's see what happens with the gauges when I do that. Notice the low side went up. You might ask me, okay, how do I know when all the refrigerant is inside the system? when both the low side and the high side manifold gauge set read the same PSIG. 75, 75. So that means that all the refrigerant is back into the system. Can I remove the gauge set? Not quite yet. What I need to do is close both the high side and low side manifold gauges. Now I can safely remove the low side. But you may notice that the high side is still reading pressure. So what I like doing to relieve that pressure safely, I go to the back of the manifold gauge set, loosen the yellow hose, I flip it, and let me say why I do this. If there's still any liquid in there, and I try to loosen this red hose right here, I can burn my hands. This way, I have control over it. And once that reads 0, I close it and tighten all hoses on the manifold for the next go around when I attach it to another system.
All right, excellent. Part 1. We'll continue later with part 2. All right, Rockstar.